In this illustration, we intend to draw the shear force and bending moment diagrams using the Abaqus software and analytical solution for the beam. In this picture, the loadings having been applied to the beam can be observed. In this problem, the shear force and bending moment diagrams will be drawn using the analytical solution. After that, these diagrams will be drawn using the Abaqus software, and in the last step, the results obtained from the Abaqus software will be compared with results gained from the analytical solution. In these pictures, the shear force and bending moment diagrams can be clearly observed. Here, the red diagrams are related to analytical solution, and the blue ones are related to the Abaqus software. Actually, this problem has been selected from Mechanics of Materials book. And here you can observe that. I will enter the Abaqus software for simulation. I will click on Create Part. I intend to create geometric shape of the beam. I will select the modeling space as 2-dimensional. From here, select Wire, enter approximate size equal to 10, and continue. I will draw a horizontal line. As it can be observed in the picture, the length of beam is equal to 3 meters. Done. In the next step, I click on Tools menu, then select Datum. From here, select Offset from Point. Select this point and enter offset equal to 2, 0, and 0. Then click on Tools menu, select Partition, select the Select Midpoint Datum Point option, select this point, and click on Create Partition. Actually, this point is the same point C. In the next step, I will enter Property module. Click on Create Material. Here, we suppose the beam is made of steel. Of course, the type of material will have no effect on the results in this problem. I'll click on Mechanical menu, then on Elasticity and Elastic. I'll enter Young modulus equal to 200 multiplied by 10 to the power of 9 Pascal. The Poisson ratio is equal to 0.3. OK. I will click on Create Section. I'll select Beam and then Beam and continue. I will click on Create Beam Profile. Here select Rectangular and continue. The size of the cross-section of the beam has not been distinguished in the book, and that is because the size of cross-section of the beam will have no effect on the results. Here I'll consider that a square with a size equal to 0.1 meters. OK. I will click on Assign Section, select the beam, done, and OK. Then I will click on Assign Beam Orientation, select the beam, done. Press the Enter button and OK. I will enter Assembly Module, click on Create Instance and OK. After that, I will enter Step Module, click on Create Step. Select Static General, continue. Since this problem is linear by nature, I will select Off option. I will enter time period equal to 1 second. But time period in this problem will not have any effect on the results. And so here any figure inserted would be absolutely right. In the next step, I'll enter load module. Click on Create Boundary Condition, select Initial Step, then select Displacement Rotation, and continue. I will select this point, Done. As you observe, there is a pin support at point A. So I will close all boundary conditions of displacement except UR3. Again, I will click on Create Boundary Condition. Continue. I'll select this point, Done. As you observe in this picture, there is a roller support at point C, which will allow movement directed at x-axis, but would not allow any movement directed at y-axis. Here I'll close the boundary condition of U2, but leave the boundary condition of U1 and UR3 free. I will click on Create Load. Select Step 1, then select Concentrated Force and continue. I will select this point, Done. As you observe in the picture, a 40 kN force is applied to point B. I will click on Create Load again. Here select Line Load and continue. I will select this line, Done. As it can be observed in the picture, a linear load as much as 12 kN per meter is applied to AC section. So I will enter the amount of line load equal to negative 12,000 Newton per meter. Here I will save the model. In the next step, I will enter Mesh module. Click on Seed Part and enter Approximate Global Size equal to 0.005 meters. Click on Mesh Part, Yes. Then I will click on Assign Element Type. Select the beam. Done. Put the element family on beam and OK. I'll click on Field Output Manager, then on Edit. Here, first I'll select Forces Reactions, then select NFORCSO option. The statement NFORCSO is the abbreviation of Nodal Forces in Beam Section Orientation. Actually, using this option, you will be able to calculate the quantity of shear force as well as bending moment. You should only take this note that this option only used for beam elements, and you can't utilize that for drawing shear force and bending moment in solid, shell, and truss elements. OK. In the next step, I'll enter Job module, click on Create Job, then click on Submit. The analysis was done successfully, so I'll click on Result. Here, you observe the deformation of the beam. The purpose of simulating this problem is to draw the shear force and bending moment diagrams. Here, the problem has been solved using the analytical solution. To do so, first, we should calculate the reaction forces at points A and C. To calculate reaction force at point A, we will only need to write the moment about point C, and by doing so, the reaction force about point A will be obtained. Reaction force at point A is equal to 8 kN. In the next step, the reaction force at point C has been obtained, and that is equal to 72 kN. In the next step, we should calculate shear force and bending moment for beam. We have divided beam into two parts in this problem. One, AC section, and two, CB section. Here, AC is 2 meters and CB is 1 meter long. First, we'll calculate the shear force and bending moment for AC section. Here you observe the relations shear force and bending moment for AC section. In the next step, we should write these relations for CB section. Here, these relations have been calculated for CB section. In the next step, we should draw the shear force and bending moment diagrams. We have used the Excel software for drawing these diagrams. Here, the green diagram is related to shear force, and the violet diagram concerns the bending moment. Now, we intend to draw shear force and bending moment diagrams using the Abaqus software and then compare the results obtained from the Abaqus software with results of the analytical solution. First, I will click on Tools menu, then select Path and then Create. Continue. Click on Add Before. First, select this point, then this one, done, and OK. In the next step, I'll click on Create XY Data, select Path, and continue. Be sure to select Undeformed statement here. Then tick on Include Intersections option, so the intermediate nodes would be selected. Here I will select the last frame, then select NFORCSO2, and this statement is actually the same shear force directed at y-axis. OK, and click on Save As. Here you observe the shear force diagram having been obtained from the Abaqus software, in which shear force is on vertical axis and the length is on horizontal axis. Here we intend to compare the results obtained from the Abaqus software with those of the analytical solution. There is only a slight difference between the results of the Abaqus software with those of analytical solution, and that is diagram having been obtained from the Abaqus software is the negative of diagram gained from the analytical solution. So we need to multiply the Abaqus diagram by -1. Here In order to compare the results obtained from the Abaqus software with the results of the analytical solution, we should first draw the diagram of analytical solution in the Excel software. Then draw the diagram having been obtained from Abaqus software in the Excel software as well, and following that, compare those diagrams together. To draw the diagrams in the Excel software, we should draw these two relations in the Excel software. I will define the first relation in the Excel software. In the next step, we should define shear force for x between 2 meters and 3 meters, and the shear force between 2 meters and 3 meters is equal to 40 kilonewton. In the next step, we should define the bending moment in the Excel software. Actually, we should define these two relations in the Excel software. In the next step, we should define this one in the Excel software. Here, first, I'll draw the shear force diagram. We have drawn here the shear force diagram using the analytical solution, and the diagram has been marked out with red color. Now we'll draw the shear force diagram using the Abaqus software and then compare the results obtained from the Abaqus software with results of analytical solution. Here, the shear force diagram obtained from the Abaqus software was drawn, but there is a problem here, and that is we should first multiply the results of the Abaqus software by -1. First, I will paste the quantities obtained from Abaqus software in Excel software. Here, the diagram having been drawn with red color is related to the results of analytical solution, and the diagram having been drawn with blue color concerns the Abaqus software. As you observe, the results having been obtained from the Abaqus software are exactly concordant with those of the analytical solution. Now, we should do the same for drawing bending moment diagram once again, meaning that first we should draw the bending moment diagram using the Abaqus software, then using the analytical solution, and after that compare these two diagrams together. The bending moment diagram was drawn up to here using the analytical solution, which was marked out with red color. Here, I will return to Abaqus software. And now we should draw bending moment diagram using the Abaqus software. I will click on Create XY Data, select Path, and continue. Here I'll select NFORCSO6 option and OK, Save As. The bending moment diagram using the Abaqus software can be observed here. As previously mentioned, we should multiply this diagram by -1. I will click on Create XY Data, then select Operate on XY Data and continue. Here I will multiply this diagram by -1 and click on Save As. Now I will transfer that to the Excel software. Here, the bending moment diagram can be observed. The diagram having been drawn with red color is related to Analytical Solution, and the diagram drawn with blue color is related to the Abaqus software. As you observe, the results of Abaqus software are precisely concordant with those of the Analytical Solution, and this indicates that the Abaqus software is able to draw the shear force and bending moment diagrams exactly and with a very good care. Actually, we drew the shear force and bending moment diagrams using the Analytical Solution and Abaqus software in this training video, and following that, compared the results of the Abaqus software with those gained from Analytical Solution, and concluded that the Abaqus software is capable of drawing the shear force and bending moment diagrams with a high precision.